This problem says a car's bumper is designed to withstand a 4 kilometers per hour, 1.1 meters per second collision with an immovable object without damage to the body of the car. The bumper cushions the shock by absorbing the force over a distance. Calculate the magnitude of the average force on a bumper that collapses 0.2 meters while bringing a 900 kg car to rest from an initial speed of. Okay, so let's do a diagram. Okay, this time we'll draw wheels. Here's the bumper, and what you do is you hit, oops, okay, we'll draw the wall touching the bumper. So you hit a wall going at 1.1 meters per second, and the bumper collapses over 0.2 meters. So the bumper hits the wall, and the wall exerts a force in that direction on the bumper, which collapses it. Okay. So the work done by the wall is F times D, and that is okay. So the force that the wall exerts is in this direction, and the displacement is in that direction. So the wall does negative work on the car. D, and the angle between the two is 180 degrees, so cosine 180 degrees, and that is equal to the change in kinetic energy of the car. Okay, so minus FWD, and that's the force on the bumper. So FW is the force that is being calculated. The final kinetic energy is 0, and that's equal to, and minus the initial kinetic energy. So the force that is exerted on the bumper is initial kinetic energy of the car divided by the distance over which the bumper collapsed. So that's 1/2 mv squared divided by d. So that is equal to 1/2. Mass of the car is 900 kg. The speed of the car is 1.1 meters per second squared, and that is 0.2 meters. So this works out too. So actually, what we'll do is we'll work the rest of those things out. So 1.1 squared divided by 0.4, and that is 3.03 meters per second squared. And the reason I did that is this is G is 10 meters per second squared, and so this is 30% of that. So the force exerted on the bumper is 30% the weight of the car. Okay, so that's and we can write that. So what you would do is, for instance, well, so we can calculate the numerical value here into 900. 2,722 newtons, but what would be more relevant is, makes more sense is divide this by 9.8 and multiply by G. So and so this is equal to 0.31, and we'll write this as the mass of the car, so that's the mass of the car, mg. So the force on the wall exerts on the bumper is 31% the weight of the car. Okay, all right, that solves that problem.